All right, guys, this is going to be the lesson for Chapter 10, Section 3. You'll be happy to note that it usually is a little bit easier for most people. Just involves a few extra rules that we've got to learn for radicals and square roots. So let's start off with this. If you get 6 square roots of 11 plus 9 square roots of 11, you'll notice that now we are not multiplying, and you've got to be careful, guys, to pay attention to when you're multiplying and when you're adding. This is very similar to 6x plus 9x. If you'll notice, when we add 6x plus 9x, we get 15x. We don't touch the variable, we just combine the numbers in front. Same thing here. If you've got two radicals that are the same radical, you don't touch the radical or the square root, you just add the numbers in front. 6 plus 9 is 15 radical 11. So that in and of itself is fairly easy. You just need to be sure and keep straight. Am I multiplying or am I adding and subtracting? If you're adding and subtracting, it's very similar to dealing with variables. Just add like radicals and combine the numbers in front. Another example would be the square root of 3 minus 5 radical 3. That's a square root right there. All right, guys, this one confuses people, even though it's intended to be easy because of that hidden 1. Put the hidden 1 in front of radicals if you need to see it. That's technically 1 times the square root of 3. Once you do that, you see again, you've got like radicals. 1 minus 5 is negative 4. The radical is just combined and left alone, and your answer is negative 4 radical 3. All right, well, here's why 10.3 is after Chapter 10, Section 2. It's because sometimes to determine if you can add or combine like radicals, you first have to simplify things. Look at this one. 5 radical 3 minus the square root of 12. Okay, the square root of 3 and the square root of 12 are not like radicals. They can't be combined. Or can they? Because you can't determine that until everything's been simplified. The square root of 3 has no more perfect squares that are multiples or factors of it, but the square root of 12 does. Isn't that 4 times 3? Again, the reason we identified that 4 is because the square root of 4 is a perfect square too. So we're going to cross out that 4, and we're going to pull it out as a 2, and we now have 5 radical 3 minus 2 radical 3. Now we can see that my radicals are like radicals because we've simplified them, and we get 3 radical 3. So big little hint here, guys, before you add and subtract any square roots or radicals, always simplify first. Okay, so let me erase these. Moving right along. All right, next little section involves distribution. What if you get, like this one, the square root of 10, parentheses, radical 6 plus 3. Well, guys, this is really no different than what we did at the beginning of the year. It's just that now we've learned how to deal with radicals too. The first step is multiplication. And then after we distribute, we got to check and see if there's any like radicals that can be combined. So what's the square root of 10 times the square root of 6? When we multiply radicals, we combine the radicals and deal with them like regular numbers. So 10 times 6 is 60. It stays in a radical. And then what's the square root of 10 times 3? Well, 3 is a regular number. So there's nothing much we can do there other than to just put 3 times the square root of 10. All right, and you're sitting here thinking, okay, the square root of 60 and the square root of 10, no like terms, I'm done. Except for one small fact, guys. We still have to simplify the square root of 60. So we're going to find a perfect square in 60, which is 4. 4 times 15 plus, let's just leave 3 radical 10 alone. The square root of 10 has no perfect squares in it. Remember to cross out the 4. The square root of 4 is 2, so this is 2 radical 15 plus 3 radical 10. You will have to get pretty good at simplifying these things so that you can do all these other operations, but practice will make perfect. You'll figure it out the more and more you do it. Remember that you're going to have plenty of time on your Math Excel assignment. It's not due till Tuesday at 4. Just don't start it Tuesday at 2. You may need to spend a little bit of time keeping these rules straight. All right, next one. This one looks a lot like FOIL, and it really is, just with radical numbers. We've got the square root of 6 minus 2 radical 3 times the square root of 6 plus radical 3. All right, this is FOIL, guys. Whenever you have a binomial times a binomial, we do first, outside, inside, last. So let's talk about the first two terms. What is the square root of 6 times the square root of 6? Well, if you've been paying attention, guys, you will remember the shortcut here. What happens when you square a square root? Well, the square and the square root cancel each other out. Yes, technically it's the square root of 36, but guys, what is the square root of 36? It's 6. So there's my first two terms, the first. Now we go with the outside terms. So first, outside. Radical 6 times radical 3, they're both positive. It's just plus the square root of 18. Although I need to notice 18 has a 9 in it, so I'm going to have to simplify that later. So first, outside, inside, these two. What's negative 2 radical 3 times radical 6? Well, it's negative 2 radical 18. Remember the regular numbers, negative 2, and if you need it, the hidden one right there. Negative 2 times 1 is negative 2, and then 3 times 6 is 18. And then finally, look at the last terms. Negative 2 radical 3 times radical 3. Well, the negative 2 is kind of by itself as a regular number, negative 2 times 1. But what's the square root of 3 times the square root of 3? It's a regular 3. The radical disappears because we just squared our square root. So let's just start simplifying this. This is 6 plus 1 radical 18 minus 2 radical 18 is minus 1 radical 18. We can simplify that in a second. Remember, there's a hidden 1 in front of that radical 18. And then minus a 6. Well, then that means these 6's cancel out, because what's 6 minus 6? 0. So I'm left with this negative 1 radical 9 times 2. I identified the 9 because it's a perfect square. The square root of 9 is 3. Pull it onto the outside. Negative 1 times 3 is negative 3 radical 2. And there's a fully simplified answer. Yes, it is a little bit involved, but all those steps use what we learned in 10.2 to kind of help us with it. All right, let me check on time. We've still got plenty of time left. And so let me show you the part of this that is the most difficult. A lot of this stuff, as long as you don't get intimidated by radicals, I don't think it's too hard. You just got to remember all these new rules for radicals that we've learned. Kind of keep them on the top of your mind when you're doing this work. Get all this erased. Sorry, it always takes a second. I wish they had an erase all feature, but unfortunately they do not on Screencastify. Okay, so here's the last part, and this is the part that you're going to need to focus in on and learn how to do. 10 divided by the square root of 7 minus the square root of 2. Now, in 10.2, whenever we got a radical in the denominator, we multiplied by the radical over itself. But this is different. What we did in 10.2, whatever was in the denominator was a monomial. This, you'll notice, is a binomial because of that minus. It requires a different rule. The rule is using difference of squares. Because, I'll remind y'all, what's a plus b times a minus b. If you'll remember, it's a squared minus b squared. Well, look at how helpful that formula is when using square roots. How do I get rid of the square root of 7 and the square root of 2? Wouldn't it be nice if I could square both of them? So that's the rule we have to use, guys, and I need you to pick up on this. This is not something that you can look at for half a second and just kind of casually think about. This is a new, very key rule. When you have a binomial, like the square root of 7 minus the square root of 2, you have to multiply by what's called the conjugate. This is the a minus b. And so over here, we need the a plus the b. And so it's the square root of 7 plus the square root of 2 over itself. Because again, guys, we can only multiply by 1, and then we're good to go. Okay, so think about this. Notice when it's going to be necessary. And then you have to also do the math. Up top, we're just going to distribute. 10 times the square root of 7 is 10 radical 7. 10 times the square root of 2 is plus 10 radical 2. So the top part is not that hard. The bottom part can be hard if you don't listen to me closely. Technically, could we do FOIL? Yes, but FOIL is probably more difficult. Instead, I want you to think about what is a minus b times a plus b, because that's what we intentionally set up here. Isn't it a squared minus b squared? It's a difference of squares situation. So what's our a term? The a term is the square root of 7. What's the square root of 7 squared? It's just 7. That's why we're doing this. And then what's the b term? Square root of 2. What's the square root of 2 squared? It's just 2. And in a difference of squares, what always goes in between them? A minus. So we end up with 10 radical 7 plus 10 radical 2 divided by 5. You would think that's our final answer, but here's where it does get even more difficult. Guys, look at this 10, and this 5. Are all three of those regular numbers divisible by 5? Yes. So we have to finish simplifying. All three of them have to be divisible by the same number, and then we're going to reduce by 5. So 2 radical 7 plus 2 radical 2, and that is a fully simplified problem where we started with that. Okay, so a little bit more involved, a little bit more difficult. It's going to take some practice and some work. But guys, remember, every single day I'm available for tutoring. You just got to come in there for tutoring. I still have a lot of students that I haven't really seen in tutoring. If you're learning it, then that's fine. But if you need help, don't sit there and freak out and say this is too hard unless you've given me a chance to work with you in tutoring. All right, so we'll finish it up there. MathXL is online. It's due Tuesday at 2 o'clock, so just stay aware of that. Get it started with as soon as possible, and then let me know if you need some help. Good luck with it. Look for the next lesson on 10-4 soon.